our today's lecture, we are going to discuss that what are the types of forces. And after that, the second important type of the chapter, that is the pressure. First of all, the types of forces are two. First is contact force. Second, that is non-contact force. Under contact forces, we are having two types, muscular force and frictional force. And non-contact forces are of three types. First, that is the magnetic force. Second, electrostatic force. And third, gravitational force. Let us discuss all these one by one very quickly. Inside our body, digestion is taking place, breathing is also taking place, and outside that we are doing lots of work, we are riding the vehicles, we are pulling the things, we are pushing the things. In all these things, our muscles are working and our muscles are either pushing or pulling the object. It means that the force by the virtue of the muscles is known as muscular force. Second type of contact force is friction. We are knowing that any object which is in motion will stop after traveling some distance. Why it happens? It is because of the frictional force applied by the surface. In our next chapter, we are going to discuss frictional force in detail. But at this point of time, both muscular and frictional force needs the physical contact between object. So we are having two things which are interacting. One is the surface and second the object which is in the physical contact, and that's why this type of forces are known as the contact forces. Then in non-contact forces, we are having first magnetic force. You all have seen the magnets. Just now I am having bar magnets, and this bar magnet is having two ends, one and second. These ends are known as the poles of the magnet, and if we are having like pole, then the magnets will repel each other, and if we are having unlike poles, then it will attract each other. Besides that, any material which is made up of iron, if you are bringing near the magnet, it will attract it automatically. So that force by the virtue of magnetic property of the substance is known as magnetic force. Then the next, that is electrostatic force. The activity of plastic scale and pieces of paper we all had enjoyed. So the force between this plastic scale and the pieces of paper, which is known as electrostatic force, because whenever we are rubbing one surface with another, so in that the electrostatic charge is present in both the substances. That means one substance loses the charge, second substance is getting the charge. As a result, one substance becomes positive and second becomes negative, and positive negative attracts each other. Negative negative, positive positive will repel each other. Third type of force, in that whenever the object are released, it could be the fruit from the tree, it could be any object which is lost from our hand, everything is falling on the earth, on the surface of the floor. How it come true, or what happens in that situation, from where that force is coming? So that force is given by the earth, and that's why that force is known as the gravitational force. Till now we are discussing that the objects should have the physical contact. In this type of forces, there is no physical contact between object. Then how can we consider that as a force? So, attraction and repulsion is also known as the kind of push or pull, and that's why non-contact forces are also existing in nature. After this portion, we are having second important part of the chapter, that is pressure. Many times we are using the word pressure and force in between or instead of anyone. But technically, scientifically, there is difference between force and pressure. Pressure we can define as the force acting on a unit area of the surface. So I can write the formula for pressure is equals to force upon area. Now you can see over here that area and pressure, they are inversely proportional. What does it mean? Inversely proportional means if the area increases, the pressure will decrease, and if the area will decrease, then pressure will increase. How can we understand this practically? So we are having very simple example of drawing pins which we are fixing in the softboard, or the nail which we are trying to fix in the wall. We are always fixing the pointed end of these things, not the head of that things. Why is it so? Because the area of the head and the area of the tip is having a difference, is having a variation. And according to this formula, less area, smaller area will get more pressure. Besides this, the sharp knife, the belts of the school bag, then ski driver, they are having the long skis, the lorries which are fully loaded, they are having more than one tires, you might have seen. Then the dams, the buildings are having broader bases. These are the practical applications of the pressure, because as the area increases, the pressure decreases, and as a result, the longevity, the safety of the building, of the construction is increased. After that, the topic for which 3 or 4 activities are given in our textbook, that fill a tube with water, tie a rubber sheet at one end and fill water in that. In another activity, take a plastic bottle, make the holes at the bottom, little bit up to the bottom, and fill it with the fluid, water or any other fluid. What you will observe? We will observe in first activity that as we are pouring the water in the tube, the bulge of the balloon is increasing. In second activity, as we are filling the water, the distance by which the water is flowing out of the bottle is increasing little bit. So these activities are concluding that fluid are also applying the pressure. Fluid could be liquid as well as the gases. So as they are flowing, they are known as the fluid, and the air which is flowing, that also giving pressure on the walls of the container or its surrounding. After the discussion of pressure by fluids, the last topic of the chapter, that is the atmospheric pressure. In that, if we are observing, so first of all, the envelope of air is known as atmosphere. We are knowing that from the surface of the earth till few kilometers, the layer of the air is over there for few kilometers. So in that situation, this air is also exerting pressure that is known as the atmospheric pressure. There are so many examples of atmospheric pressure, but simplest one, that is the sucker, the vacuums which we are fixing anywhere. It sucks all the air, and as a result that area is getting vacuumed. Besides all that, when we are standing, when I am here, I am also facing the pressure of the air on me. You can see the figure in the textbook. That air column above all of us is giving lots of pressure to us. Then the question arises that why we are not able to feel that pressure. So the pressure which is given from the outside is balanced by the pressure inside our body by the different fluids and the water present in that. So we are having both the pressure, outward pressure of the atmosphere and inward pressure of our body, and as a result we are not able to feel this pressure, but on all of us the air column, which is very longer, which is giving us the air pressure which is equivalent to the almost 2 baby elephants on us. The device which is used to measure the atmospheric pressure is known as the manometer. And if we are doing the calculation, then the weight of the air is approximate 225 kg in 15 centimeter by 15 centimeter column. Weight we will discuss in 9th standard in detail, and at this point of time the unit of weight is kg. Even we can convert this kilogram into Newton also. Newton is also one type of unit which is used in the memory of the scientist Newton. The constant value of the gravitational constant, that is 9.8, which we can take round off as 10. So if I am converting this 225 kg into the Newton, it becomes 2250 Newton. So concluding the chapter, we have discussed force and pressure. Force is a push or a pull. Lots of examples, exercise questions are given in our textbook. That suppose a rocket has been released. Which type of forces are acting on that? So we are knowing that gravitational force, the frictional force, is acting on this object. Likewise, the examples which are discussed for push or pull, the question could be asked to you related to that. Then the simple numericals based on the formula of pressure can also be asked to you. That suppose we are having the force of 5 Newton, as I said just now, and if we are having the area of 10 meters square, so 5 by 10, so 0.5 Pascal is the unit of the pressure. So for the examination point of view, go through all these concepts properly, and as we have discussed the exercise question answer, try to solve that also. Thank you.
आभार।